Hey guys, it's Nick with Precision here, and today I wanted to talk to you guys about the fundamentals between CO2 and solvent-based extraction. What we want to talk about is the fundamentals of the solvent. We're going to start with CO2. So CO2 typically in the atmosphere, as you guys probably well know, is a gas, right? It's all surrounding us everywhere. But in order to make it a solvent, it needs to go into what's called subcritical or supercritical phase, right? And what happens with a supercritical phase is you're compressing and you're heating that gas in order to make it into a fluid form, right? So typically called supercritical fluid extraction, and if it's at the lower end of that range, subcritical fluid extraction. Now, this technology has been around for years, right? It's been used in coffee, it's been used in vanilla, types of artisanal extracts. It's really, really good for decaffeination. They use it in dry cleaning, right? So the technology has been around, and about 10 years ago when cannabis really started getting large and people started looking towards cannabis extracts, they said, hey, why don't we try this supercritical CO2? So the history of the solvent is that it's been used very widely, and people look to repurposing it into the cannabis industry, right? Which they started to do maybe 8, 9 years ago, and it started to really get big about 6 or 7 years ago, right? So all these supercritical CO2 applications popped up for cannabis specifically. And when you look at the fundamentals of the solvent, right, the difference between CO2 and a different solvent like hydrocarbon or ethanol is CO2 doesn't do a great job at actually extracting the cannabinoids, right? So you've got your cannabinoid structure that's contained within your trichome, right? And your trichome is a mushroom-like shape on the outside of the leaf of the plant, right? And that's what contains all your goodies. That's your terpenes, your CBD, your THC, your CBN, your CBG. All those things are contained within that mushroom trichome structure, right? So what we want to do with a solvent of any kind is dissolve that structure, right? And isolate those molecules. Now, supercritical CO2 can do this, right? But it's a very weak solvent. So if you think of a solvent and you think of a molecule like a lock on one side and a key on the other, right? You want to find the perfect key that goes into the lock, and you're kind of sliding it in there, you're turning that lock, and that door is opening right away, right? With supercritical CO2, it's kind of similar to trying to jam a screwdriver into the lock, right? It's going to work, right? But it takes a lot of power, a lot of pressure, right? Which is why you see these systems that operate between 1,500 to 5,000 psi, and because of the nature of the solvent, right, the solvent has to be repeatedly passed over that trichome structure, right? So we're continuously passing this solvent that doesn't have great solubility with cannabinoids and with that trichome structure of the plant over this plant in order to get our goodies out, so to speak, right? So that's why CO2 units have a long cycle time. Typically what you're gonna see is anywhere between, on the very low end, 2 hours, which will diminish your yield and diminish your returns on your actual processing. And you're also going to see longer cycle times the more material that you put in there generally, right? So these can be manipulated in a number of different factors. A lot of the CO2 companies have drastically improved upon the old days. The old days it was 8 hours per run, right? They've improved that by running things like subcritical, running things like higher pressure, sometimes up to 5,000 psi. But it doesn't change the fundamentals of the solvent, right? The solvent is not the best key for our lock in order to get those cannabinoids and those chemicals out of the plant that we're desiring, right? So that is a fundamental overview of why CO2 technologies aren't as applicable. Now, when you look at the equipment side of CO2, right? Obviously, it stands to common sense that if you got to have something that's going up to 1,500, 2,000, 5,000 psi, right? You can imagine at scale, it's simply not economical or feasible in order to have those technologies at scale, right? Because if you think about a gigantic vessel that needs to go to 5,000 psi, right? Think about the amount of engineering that has to go in there, the shell thickness, the valve, the safety precautions, right? Obviously, when you're working at those types of pressures, there's a fundamental safety concern. Now, if it's properly engineered equipment, of course the machines operate safely. There's not a thorough history of accidents or things like that, but it takes more dollars, right? Which is why dollars to dollars, when you're looking at CO2 equipment, the equipment is actually quite a bit more expensive than solvent-based, right? So what really happens with all of this total scenario, right, is you start weighing out all these variables against CO2, against solvent-based. against the equipment, against how you're going to scale, what's right for your business, how you're going to apply these technologies to your end products, right? And that's a lot of what we do here at Precision is we look at our clients' needs, we understand what it takes for an end-to-end process to integrate, and that's part of what differentiates our company is that we are end-to-end process integrators, not just somebody that's going to sell you a piece of equipment and walk away, right? So what I'd like to do is compare that with the fundamentals of solvent-based extraction now, right? And when we talk about solvents, we'll talk about the three most popular, which would be butane, propane, and ethanol. And there's a lot of other solvents out there that work. There's a lot of other solvents that may come into play in the future, but we're going to focus around the primary three that are used today in the cannabis and hemp industry, and we'll talk about how those apply more readily to large scale, especially in CBD production and hemp production. So on the other side of this coin, I want to talk about solvent-based extraction, right? And I want to talk about how it compares with CO2 specifically. So let's go back to our lock and key analogy, right? Our lock and key analogy is we want to find the perfect key to go into the lock, right? And on this side is our molecule that we're trying to extract, and on this side is our key. Our key is our solvent, right? And we've not found generally a better key in the history of extraction over the last decade or so than butane and propane, right? So butane and propane are non-polar solvents with a light boiling point, right? And what that's going to yield is it's going to go in there and it's going to bind to all of your cannabinoids, your terpenes, and the desirable aspects of the plant, right? So if you ever look at artisanal type of products, most of them are made with butane and propane, right? You get that really beautiful light color, that terpene-rich smell, right? Which is very, very applicable to artisanal cannabis markets, and it's also very, very applicable to moderate scale, right? Different types of manufacturing and making different products, right? Now, we start to make a little bit of a paradigm shift, right? Because butane and propane, as most of you probably well know, are flammable solvents, right? So, and they also contain a little bit of pressure, which means it costs a little bit more money to engineer the equipment, right? The shell thicknesses on the equipment have to be a little bit thicker, but not like CO2, right? At CO2, we're talking about 5,000 PSI. Butane and propane, we're talking about anywhere from 50 to 150 PSI. So much, much lower pressures, much safer working environment overall, right? But we want to keep these vapors contained so they're not ignitable, right? And we want to stay in a Class 1 Division 1 room and take all these proper safety precautions. Now, our company's done thousands of installations of hydrocarbon equipment across the entire world at this point, and we can honestly say that I think we're experts in hydrocarbon extraction, and we understand that hydrocarbon actually does pull the best terpene profile, the best cannabinoid profile out of the cannabis plant. However, at large scale, you can start to see where the actual hurdles come in, so to speak, right? So now, how do I process, 2,000 pounds a day with hydrocarbon on a large scale? It starts to get very costly and very engineering heavy, let's call it, right? Because you have to have all of these different vessels, everything has to be under pressure, everything has to be Class 1 Division 1 rated, right? So it's not really feasible for large scale CBD extraction or large scale hemp extraction. And what we like to usually say is if you're an artisanal brand, that means you're processing about 1,000 pounds of input biomass per day or less, right? Once you start crossing over that threshold, the cost of engineering the equipment, the cost of the redundancy in the batch equipment, and the cost of the hydrocarbon equipment becomes prohibitive, right? And it's why you see a large trend towards ethanol. So let's talk about ethanol from a chemical standpoint for a minute, right? So going back to our lock and key method. Ethanol is also a very good key for our lock, right? But the problem with ethanol is because the polarity of the solvent, it's an extremely polar solvent, right? So the extremely polar solvent, yes, it will bind to our cannabinoids and our terpenes. The problem is that it's also going to bind to chlorophylls and to other water-soluble or undesirable compounds within the plant. Now, traditionally, what everyone has done to combat those water-soluble molecules or those chlorophylls is they've chilled their ethanol down. So those of you that are watching this video that are experienced, you may very well know if you run your ethanol at -40 or below, generally you're able to bypass a lot of the chlorophylls, you're able to bypass a lot of the lipids and the phosphide profiles, right? Things that are gonna gum up your process downstream, right? But the problem is that how do you chill now all this ethanol on a massive scale? So we're in a different era now, so to speak, right? How do we use ethanol on a scale for CBD that we're doing 10,000 pounds a day? Well, it comes down to properly engineered equipment, right? It comes down to proper mass balance. It comes down to proper post-processing procedures where you need an end-to-end engineered solution, which is what we've done with our KPD series, right? So it's not just pouring ethanol over plant matter, right? There's refinement of the product, there's variabilities in the biomass, there's all sorts of things that are coming down the pipeline, right, that affect your yield, they affect your distillate quality, they affect your crystallization, right? All these different variables that you need to have a thorough understanding of, right? So processing at scale, it can be done, you just need to have an understanding and a strong team that understands all these variables and how to combat them. But from a fundamental standpoint of scaled extraction, ethanol is fantastic because you don't have the pressures. There's absolutely zero vapor pressure, which means none of your vessels are under pressure. You're not operating under pressure. It has significantly less flammability than hydrocarbon, and it's significantly safer than CO2 in the fact that it's not pressurized, right? And people like ethanol because most of us go out to the bar every Friday and Saturday night and drink it, right? We ingest it. It is a relatively safe solvent, generally recognized as safe from the FDA. So let's talk about an overview of the common misconceptions that come with solvent-based extraction, right? People tell you, oh, you extract with a solvent or you extract with butane or propane, you're gonna have residual butane or propane in your product. That's absolutely not true. So what happens is once the product is extracted, there may be trace amounts of butane and propane, but it goes through a heating and purging process, right? Typically that's done either in vacuum drying ovens or in decarboxylation or in distillation, right? That's gonna remove that solvent, and there'll be 0 parts per millionth of any sort of residual solvent, right? Same thing with ethanol. Ethanol is a little bit harder to take off because it has a higher boiling point, right? It's not as volatile, doesn't vaporize as easy. But the same thing, right? It's going to be pulled off in decarboxylation or in distillation. And it's ironic because a lot of the people that preach anti-solvent extraction, right? They're in the CBD market and they realize once they get to crystallization that they're forced to use pentane, which pentane is a group D hydrocarbon and needs to be purged, needs to be dealt with in a Class 1 Division 1 room, needs to have all these parameters. So again, understanding your process and working with really, I could say, educated people, not believing a lot of the marketing hype that's out there because everybody wants to sell you equipment, but in the end of the day, do they know how to integrate your process end to end? Do they really understand the science of what's happening behind the process? And have they done it before? Do they have a long operational history? So these are things that I would definitely, ask the people that you're potentially doing business with. A lot of what we do here with our R&D team is that we test these processes, we test new parameters. We're working on ways to optimize the extraction process. Our company, while we're an equipment manufacturer, we're a process integrator, but we always focus as an innovative technology company, right? So we're always looking at disruptive technologies, what's going to change in the future market trends, what's going to happen to these markets, how do we get to scale for lower cost, and we look at all these variables, and that all starts on the bench, right? Which you guys can see the lab behind me. We work with our team very closely, and we're always working to find a more efficient, more effective process, right? While still being able to integrate the existing processes and making them work really well, right? So I thank you guys for listening today. You can shoot some comments below or shoot us an email, give us a call if you have questions. We're happy to help, and we've got a large staff that can help you guys out. And thanks for watching the video. Appreciate it.